Hi, everyone. So I'm Kumbirai Tanekha. I'm a software engineer at Cyberark Conjur, and I'm here to talk about some best practices for securing containerized applications. Right. So automation, right? Automation is great, and I think that's for the most part why we're all here. I think we appreciate what value automation brings. But if you have automation without considering security, then it doesn't really work out, right? Because if automation means getting more things done faster, and automation without security, well, what does that mean then? Like, it means you could essentially ruin yourself faster than if you were doing things manually. Right, so I always like to kick this off with a little bit of confession time, right? They say that confessing is good for the soul. So, you know, amongst yourselves, you can just think about this a little bit. Like, what are some of these sins that maybe you've perpetrated? I know for a fact that I've done some of this stuff in, I guess, in my journey to become a better developer. And this is very common stuff like storing secrets in source control, manually configuring things, embedding secrets or passwords. These are all things that kind of lead to exploits. And I think we can all agree that these are problems. These are problematic because this could essentially reveal the keys to the kingdom and ruin your company. Right, so why do we actually care about this stuff, right? So exploits are targeting the application supply chain. And this is the thing that's happening more and more as we move into, I guess, the cloud that much more, and we have containerized workflows and all that sort of stuff. So these are some high-profile cases, and actually there's a recent one, a more recent one where I think it's from Uber, where essentially if you're using something like enterprise GitHub, right, and you put your secrets in source control, you might think that you can get away with that, but no, you can't, because within a minute, like, some bot out there will completely scrape through and grab your secrets, and they'll be in your AWS instance or whatever else, right, within a short period of time. So this is a legitimate problem. And what these secrets are generally like API keys, SSH keys, all that sort of stuff, right? The things that we need in order to make kind of private connections to our resources. Right, so every time that I kick off a conversation about security, I kind of like to put perspective into consideration because I think perspective matters. As a developer, or just in general, I feel like there's a traditional view of security which is a little bit problematic. And what this is it tends to think about security from the standpoint of like, we need to do so much work in order for us to actually get security. Like, it's this thing that needs a large amount of investment, and in terms of like what it gives you back, well, that doesn't even come into consideration. And it's the kind of thing where there's a lot of hurdles in terms of communication between teams, because generally, I don't know, SecOps are responsible for security. So you have to like give a ticket to them, wait for a while, and then eventually you essentially get your answer like in a week or so. And that's blocking you, because as a developer, maybe you're working on a core feature and you need to get this end-to-end as fast as you possibly can, but you can't do that because there's something blocking you. But I think we need to kind of counterbalance this traditional view of security with an essential view of security, where we think about security from the standpoint of something that helps prevent bad things from happening, right? It prevents the destruction of your company. It prevents, yeah, that's for the most part. It prevents the destruction of your company, because that's all there is, right? And yeah, I think if we start thinking about security from this standpoint, then we can start thinking about how to kind of make things better. So in trying to make things better, we have to think about what is success criteria in terms of security. And I think there tends to be this naive way of looking at security from the sense of like, well, we didn't get hacked. But that's really not good enough, right? That's a bit of a negative way to look at measuring security. I think a better way to kind of measure, success criteria for security is something along the lines of like increasing the good and decreasing the bad. And what the good and the bad are is something that I'm going to cover in the next slide. So the good and the bad really in this sense is something along the lines, like something that kind of matches DevOps in general, right? It's you want to increase your velocity, you want to reduce friction, workflow blockers, operational workload, all that sort of stuff, right? And when we talk about, I guess, security success criteria in terms of business benefits, then I think we can start kind of strategizing how we move forward. Because now, when we think about the impact of security, we can think about it in terms of something that allows us to increase our velocity while marginally, if at all, increasing risk. And I think this is a much more robust framework in which to work from. And I think this is generally what people think about when they talk about something like DevSecOps, right? Yeah. Right, so let's kick off with some not so good practices. And these are bad. So storing secrets in source code. Already talked about that. We can comb through your repository very fast, so we can get access to all your secrets. And some of these are, I guess, bad patterns in terms of how you actually give privilege. So one of them is overprivilege, right? Giving application access to more secrets than it actually needs. And this is problematic because it's bad enough that your application could get compromised, but when it does get compromised, it means that if it has access to all the secrets, then, well, it's screwed. Ignoring auditing. If you don't have any proof, did it really happen? And this is a huge problem because, compromise is something that happens. Like, I feel like we should design for failure as opposed to kind of assuming that things are going to work out. And when things do fail and when you do get compromised, auditing is something that really helps you out. And last but not least, doing things manually. And this is a very easy kind of thing to do, especially as a developer, right? Because I know that at times I've cared more about the features that I'm writing than like whatever security considerations that there may be. This is something that I've had to learn as I work at a security company, but prior to this, I think I had more focused about getting end-to-end as fast as I possibly could. And this is where things get really, I guess, you get huge headaches because none of this is reproducible, not reliable at scale, but when you do things manually, human error creeps in, and that's when you really mess up. Right, so let's talk about some good practices. First and foremost, you have to encrypt your secrets, right? That just means that it's not very easy for people who have access to like the ciphertext to actually make sense of what they're looking at. You have to rotate your secrets, so that just means change them frequently. Make sure that, if somebody does get access to your secret, maybe it's only valid for like the next couple of hours. Make secrets ephemeral. And what that means really is dynamic retrieval. So that means when your application needs a particular secret, that's when it gets it. And once it's used it, get rid of it. There's no good reason to keep it around. Authenticate all requests. And this is the zero trust, I guess, principle. And essentially what this means is I need to know who you are in order for me to actually partake in any transaction with you. Authorize minimally. And this is, I guess, the opposite of overprivilege. This is least privilege, which is to say that you should only have access to the secrets that you need in order to get your job done. And by you, it means people, machines, all the same. Audit everything. And this just means that you have a trail of everything that happened, right? And preferably an immutable trail. Last but not least, automate all of the above. And I think generally when I come along with this list of like good practices, people then turn around and say, well, if you take away the automation part, that seems like just the traditional view of security that I mentioned earlier, right? Because that's a lot of work. Like how am I going to have it so that every single developer is able to encrypt, rotate, authenticate, authorize, all of this stuff? Like this seems like a lot of work. This is a lot of consideration that your typical developer doesn't want to get into the implementation details of this. So what I'd really like to impress upon everyone here is that there is a way you can get this. There is like a Nirvana state, right? Like where you can essentially have all these good practices, but then you can kind of almost like get them for free so that they kind of integrate very deeply with your workflow, so that your workflow supports velocity and enhances security at the same time. We want to make the secure thing the easy thing to do, right? I think kind of practicing good security essentially needs you to look at it from a lifestyle point of view, right? It's not something that you just do overnight. You have to be consistently doing it always. And yeah, this would mean something along the lines of like security configuration as part of your development flow, that means essentially the rules that dictate your security are part and parcel of your code repository. And a really important part is, like with this Nirvana state, what you essentially want is your security tools and your developer tools and your application code to be kind of separate so that they can grow independently, so that they can be optimized on their own, right? Great. Cool. So the question that always leads from this is, how do you actually apply these ideas, right? So that's what I'm intending to show you. So let's just consider a typical case of overprivilege. I'm using Ansible in the middle for configuration management, but you could take anything else. You could take Puppet, you could take configuration management tools, you could take orchestration tools. It's all the same, right? Generally what happens is you have this essentially central attack target whose job is kind of to provision the machines around it, right? In the case of Ansible, you can run a playbook and it will configure the staging of the production environment. But before it does that, it actually speaks to a secret store, and Ansible kind of has access to all the secrets. This is a typical case of overprivilege. And then it passes all these secrets out to the staging and production environment. This is problematic because if anybody compromises Ansible, then essentially they have the keys to the castle. And there's not really much you can do. So hopefully we can do something better than that. And I just wanted to kind of focus on the fact that secrets, in the same way that they're needed in Ansible, are ubiquitous within kind of the CI workflow. If you're thinking about a typical use case where you're starting from GitHub into Jenkins in order to run your tests and stuff, and then pushing to like a Docker registry, across all of that workflow, secrets are required. And the question is always, where should I keep them? Like, how should I make them more, I guess, secure? So yeah, this is a problem across the whole CI workflow. So the solution that I'd like to propose here to secret management, and it's essentially the solution that we use at Conjur, is built on top of the idea of identity, right? We have human identity and we're used to this because this is essentially how we have security for all of the different kind of applications that we use. We have a, I don't know, email address and password. You can have several layers of like multi-factor authentication, all that sort of stuff, right? This is something we're very used to. But something we're not so much used to is the idea of machine identity, that your application, that your machines can actually have an identity such that you can then do everything else that you normally do with human identity, which is authenticate, authorize, and then be able to audit. So as I said, if it can be identified, it means that access can be managed, right? It means you can authenticate all requests, you can authorize with the least amount of privilege, assuming that you have some kind of model in order to actually give permissions. And you can audit everything, because if you know who's who, then it's relatively easy for you to kind of go back and say that, okay, this person did that, or this machine did that, so then you have a trail that you can work with. And what's even better is if you can do all of this using code, because if you have a means of establishing machine identity and human identity with code, then the rest kind of just follows, right? Yeah. So machine identity with something like Conjur, which essentially gives you, which essentially builds on top of, identity, works something like this, right? So the pattern that I had earlier, it's a very typical pattern, but this is, I suggest, a better way of approaching things. You have Ansible still doing its role of configuration management. It speaks to the staging and production as usual. However, you can then see that now every single application actually speaks to the secret store. And what happens throughout a typical conversation is authentication, authorization, auditing, and if you have the permissions to actually get any particular resource, then and only then do you get the resource. Otherwise, I don't know, you get maybe a 4-3. So yeah, that's essentially the offering that we have, right? So we have Cyberark Conjur, which is a product that is essentially secrets management. We have an enterprise offering, which isn't something that I'm going to cover too much right here, but it comes with all the bells and whistles. So if you want to talk about that a little bit, we have a booth outside. I'd be more than happy to go into that. But what I'd really like to impress on everyone here is the fact that you can get all the benefits that I spoke about earlier just from the open source version. And That's available at conjur.org. We have a GitHub repository where everyone can get involved and kind of become part of the community, all that stuff. So a part that I kind of glossed over is the idea that like once you authenticate and you can just authorize. And now you might be asking, like, how do we actually do that? And how we do that at Conjur is through policy. And I don't think it's something that's specific to Conjur. I think policy is a great way for you to approach essentially the declaration of who has access to what, right? So at Conjur, how we do it is we have kind of this this structure of policy, which is essentially YAML files, and I'll go through them in a little bit. What they are is quite robust because they're human readable and they're machine readable, and they're also machine enforceable. So that means that internally, when I present a policy to Conjur, it actually passes it and makes sense of it and executes it using like the engine, the policy engine that we have within Conjur. And because it's human readable, it means then it can actually be used as a tool for communication as well. So one of the things that gets in the way in terms of like the security conversation is trying to hide as much information as you possibly can. But something like policy doesn't necessarily need to be hidden. It's something that you can actually collaborate on. You can have it so that the policy could be shared so that everybody could look at it. But more importantly, the policy allows you to kind of branch off because the way that we have policy is it's role-based access control, right? So it means it lends itself to a structure like a tree very easily, right? So it means that inheritance and all that sort of stuff is very easy. You can keep it all very dry, and you can isolate who has access to what because you'd have one policy for staging and one policy for production, and the production one is owned by SecOps, and the one for staging is owned by developers only. And really what policy is, I think in terms of like a metaphor or whatever, is something along the lines of database schema. It doesn't change very often, but it's the thing that kind of keeps track of the structure of your system. And in the case of like a secret management solution like Conjur, the policy acts as essentially the thing that dictates your security rules. And what that looks like is generally something along the lines of this, right? So you have the policy which you specify. You can give it an identifier. You can give it some annotations, which is just essentially metadata. So you can give a description for what it is. And within the body of the policy, there's kind of a logical model here where you specify some roles, which are essentially either hosts, and that's what kind of encapsulates machine identity, or users. And then you have like other kind of groupings on top of that. So you can have layers, which are groups of hosts, and you can have groups, which are essentially groups of users, or could also include hosts. But yeah, that's just the conceptual model that we have here, where you essentially have some roles that you declare. And in this particular instance, there's a declaration of a layer called app, and there's a declaration of this pattern that we use called a host factory. And this is very specific, right? This is for the use case where you're not trying to give identity to 3 machines that you know their IP addresses and all that stuff. You're trying to actually have something like Ansible go out there and discover maybe 100,000 nodes, and you essentially want to enroll every single one of them. And what a host factory does is it issues out a token, a short-lived token, and essentially something like Ansible can pass this to all of the different nodes, and each one of them can come along, pass this to Conjur, and essentially ask for an identity within Conjur. And then all of that just sort of happens, and I will show you that as part of the demo. So yeah, this is one section, roles, and then the second section is secrets. And secrets is essentially declaring the variables, right? The things that are going to change. So an OAuth token, a password, all that sort of stuff. You can put annotations on them. So that means you can give descriptions. And with annotations, you can actually do really interesting things in terms of like, for example, if you wanted an automatic rotator. So this is how we essentially do this, right? So if you give an annotation that says that this should be rotated every 12 hours, et cetera, all of that will end up just happening in the background. And the last part, last but not least, is entitlements. And essentially what this is giving permissions And it works in a very hierarchical fashion where if you belong to a particular group, well, it's role-based access control, and I'm sure you're all familiar with it. If you belong to a particular group, then you inherit all the permissions, unless if you've been made an exception or something along those lines. And as you can see, this is all very much human readable, as I said earlier, and also machine executable, which is great. Right, so what is the typical workflow with Conjur? So you define access with Conjur policy using declarative, basically YAML, right? That's your declarative policy. And this allows you to leverage the scaling power of role-based access control because you can have several policy files kind of dotted around, and you could even have different repositories with different parts of your policy. So it allows you to kind of scale out independently in terms of policy. You can use this as a means of collaboration, and you can actually peer review your policies so that everybody is happy with it. It's basically like code, except it's very much declarative. Once again, you can store policies in version control for history or whatever reason. So once you have policy, it means that you kind of have the foundation, which means if you're using the host factory token pattern, you can have it so that you have hosts enrolled, they join a particular layer. If that layer has permissions to particular secrets, then, well, that particular host now has access to those secrets. So when you establish identity by essentially creating a host and then giving it that particular identity, which is in the form of like, let's say a host ID and an API key, and it can go to Conjur and essentially authenticate, get an access token, which is short-lived. What you can then do is you can leverage this identity in order to retrieve secrets and credentials. And while you're doing that, you're going through the same process of authenticate, authorize, audit. And essentially the end goal for this is you win because within all of this, there isn't really any space for like, well, you could be imperative if you wanted to, but you don't need to be, right? So it means that this is very smooth. It's the equivalent of like how when you're dealing with something like Git, you don't have to implement every single step of Git. You type git commit, git push, and you're done. And it's something that's very, like, it's almost like second nature for every single one of us as developers. It's very easy. Great, so I've been yapping on for a while. I would love to demo something. I'm going to be using Ansible as the use case before. I'm going to use Docker Compose to kind of orchestrate everything. So, yeah. Cool, so just to kick things off, I'd just like to show you the Docker Compose file that I'm working from. So within my Docker Compose, I'm actually using the open source version of Conjur. Is this visible to everybody? Like, do I need to increase the size or anything? Yeah? Is that better? Oh, cool. Is the command line okay or also needs improvements? Because unfortunately, that's the part where I don't know how to increase it there. Anyway, yeah, so I'm hoping that everybody is familiar with Docker Compose. Docker Compose allows you to essentially abstract running containers into like this idea of services, etc. So what I have here is I have Conjur running. It has a Postgres database as the backend. I have a container that's responsible for running Ansible so that my machine didn't actually need to have Ansible. I have a service for the Conjur command line interface, which I can kind of issue commands towards so that I can run policy and all that sort of stuff. Even though Conjur is API first, there's no point in me going through the API when I have a command line interface that allows me to kind of streamline all that. I also have two services that are important for illustration purposes here. So I have my application in staging environment and my application in production environment. And this will allow me to kind of demonstrate how easy it is for you to essentially be working on staging and production all at the same time. And last but not least, I have the Conjur proxy Nginx. And essentially what this is giving you encryption in transit, I guess, right? So secrets in Conjur are encrypted at rest. But in transit, you can just have SSL, TLS, all that good stuff. And I'm just giving an example here where you essentially use Nginx, you generate your SSL cert, and you get that going. Cool. Right. So the first script that I'm running here will essentially kick off Docker Compose, and what that does is it brings all these services to life. I have a really cool tool that I'm using, which is called Weave, which I hope you might all be familiar with. And what Weave will do is it will show me what's happening in my container space. So as you can see, I have one Nginx, great. I have Ansible here, but we don't really care about this for the moment. And I have the several versions of my application for staging and production. So there's 4 for production and 2 for staging. And I have Conjur and a Postgres backend. And as you can see with this arrow, Conjur is communicating to this backend. And we can actually see that in the logs as well, because we've just kicked off that. Right, so I'm going to quickly start a CLI shell. So this means I'm talking to the Conjur CLI. I'm going to log in as admin, which will allow me to issue some commands, like have a look at what variables are present, what hosts are present, that sort of stuff. Great. So if at the moment I type var list, you'll see that there's nothing. Like I have nothing in here. I have no hosts. I have no layers. I have nothing. So the first thing that I'm going to do is load my policies. And I have a script that's responsible for that. We could dive into that a little bit, but it's very simple. All it's doing is it's running policy load and a particular policy file, and it's doing that for several different policies. But what I would like to do as this runs on the right is just go through the policy. So here's the top-level policy file. And as I said earlier, it's possible for you to essentially separate or namespace your policies so that you have a different one for staging and a different one for production. And as you can see, the owners are different people, right, or different groups. We have developers for staging, and we have security ops for production, right? And I have a different policy, which just allows me to kind of like specify some users. So we're not just considering machine identity, we're also considering user identity. Great. So here comes the policy that gets applied to both of these, I guess, sub-policies, right? There's one for staging and there's one for production. And we have a policy for my app. And as I said earlier, you declare some variables. And in this case, we have a database username, a database password, and a Stripe private key. We've put some metadata so that it's more easily described. We declare a layer, and this layer doesn't have anything in it. And as I said earlier, a layer is essentially like a grouping of hosts. And then I declare a host factory. And as I mentioned earlier, the host factory is a mechanism for us to auto-enroll hosts. At the bottom here, I'm just specifying some groups and essentially giving particular permissions to those groups, right? And in this case, I'm essentially saying that let's give the permissions of read and execute on the group secrets users. And then at the very bottom here, you can actually see that I'm granting the role of secrets users to the layer. And remember, the layer is completely blank right now, but I'm gonna essentially have it so that I configure a machine identity for some hosts, and they can become part of that layer. And it all happens very much automatically. So once again, if we jump in and we have a look at, after running the policy, what do we have, right? So at the moment, we can see that we have 2 layers, and that's a consequence of the policy that I just ran. You can see that I have a production and I have a staging one. And if we have a look at the hosts, oh, sorry, yep, that was the same thing. And if we have a look at the variables, at the top here, I specify database username, database password, and Stripe private key. And since this branch policy is actually being run both for the staging and the production environment, it means we can expect there to be a database username for production, a database username for staging, etc. And you can actually see as we scroll through this that there is indeed. Well, that is indeed the case. At the very bottom here, you see something interesting, which is we're getting a 404 not found for basically all the variables. And it's because when you instantiate variables through policy, you can't actually set the value through policy. That's something that you have to do through the API or the CLI or some other means. policy is just for declaring the variables. And in this case, if the variable hasn't been instantiated or the secret hasn't been instantiated, then you get a 404. So that moves us swiftly to the next part, which is to set secrets. So I can run over to set secrets. And once again, I think maybe this might be too small, so I'm going to... Right, so you can see that this is actually it's a very simple script. It's also using the CLI, and it's adding values to every single one of those variables. So for the, I guess, staging environment, we're prepending stuff with staging, and we have a hex in front for the password and private key. And for the username, it's just foo environment user. We've added the values, great. So we go back to the CLI. We run vars list again. And yep, as you can see, these are the values that are actually present within the database, right? So I'm logged in as admin, and I'm able to get access to everything because, well, I'm basically God in this. And yeah, so we have the setup for Conjur actually done right now because we have the policy that dictates the rules, and we have kind of the secrets with the values already in place. Now comes the configuration management tool, right? The integration point. So what we've done with Ansible is, and this is what we do with all other tools, we try to have kind of like a first-hand integration, and I'll just go ahead and show you that. So I have demo.sh here. Sorry, nope, that's not the right one. So deploy. And what deploy does, and I think it's good for us to just walk through this a little bit, is it grabs the API key, for my admin user, great. And then we generate a host factory token, right, using the CLI. And it's only valid for 5 minutes. And we're generating it depending on what environment we pass in. So that's why when I run deploy, I'm going to have to kind of append staging, right? But I haven't run that. And then we run a playbook. And then I think it's worth me just running over to the playbook that I have. Cool. So here's the playbook I have. And if you're familiar with playbooks, there's two major chunks to this. You have a role here, and this is a role that we have at Conjur, which is called configure Conjur identity. And then we have a bunch of tasks. And these are very much like you're writing in line what you want to happen. So in this case, I'm finding the current running application on a host. If it is indeed running, I'm going to register it in a variable. I kill it, and I essentially start the application, right? And that would be the typical use case in the old pattern where you have that central attack target, as I said earlier. You wouldn't have any of this summon stuff. This is very much Conjur specific for the moment. In any case, yeah, I have a playbook, and the playbook is responsible for essentially provisioning our application. What I will do just now is show that. So these are the IP addresses, or rather the ports that have been assigned for my applications. And if I go over to any one of the staging ones, you notice that it isn't actually working at the moment. And it doesn't have to work because if we hop into the Docker Compose, we will see that for staging and production, the entry point on command are just sleep infinity. So these are essentially like they're forever alive, but there's no process running on them. So I'm using Ansible in order to essentially configure them and then kick off the process. And that's what I'm going to do in a moment. So if I head over here and I write deploy, staging, while I run that on the right-hand side, I'm going to quickly go into the test app and just show you, I guess, the internals of what my application looks like. So as you can see on the right-hand side, we just generated a host factory token where, and I'll just go up a bit, we're configuring identity, and what that does is essentially goes out to Conjur, gives it the host factory token, says, hey, give me an identity, gets an identity, essentially kind of writes that locally into this identity file that is only root, well, that only root can access, right? So there's no way that anybody else can kind of get to that. And we're essentially done. I'm going to come back to this foo.rb in a moment, but if I refresh this now, you can see that the application is actually up and running. And what's just happened here is this application established identity, right, using the host factory token pattern, went out to Conjur, grabbed the secrets because it actually had access, went through authenticate, authorize, all that good stuff, grabbed the secrets. They were passed into its environment variables, into its environment, rather. And now we have access to them. And I guess this allows me to kind of dive into Foo a bit more. So Foo is actually a very simple application. It has a single route. And what that route does is it essentially renders some text, right? And in this case, it's like HTML, but great. So it grabs the rec environment variable, DB username, Stripe API key, and this password value, which we can go into more detail. And you might be like, okay, so where are these environment variables coming from? So in a typical use case where somebody is actually putting their secrets in source code, you would expect a secrets.yaml that essentially has these files, and something is just reading them. And as we already covered, that's not a good practice. So let's have a look at the secrets.yaml that I have. So that's interesting, right? So there are no secrets here. All I have here is essentially the identifier in Conjur of where that secret lives. And I'm actually able to kind of prepend this environment variable, which says behave differently depending on what environment you're in, right? So what actually happens in the background is, so we have this role, right? And what this does is it establishes machine identity. And then we have a bunch of tasks. And one of the tasks is to install summon and summon Conjur. And what summon is a really clever tool, which, like this isn't specific to Conjur. What summon does is it essentially, it has providers. And what the providers expect is a path to a particular secret. And when someone gives them this path, the provider should give back a secret. And summon Conjur is a provider that uses Conjur as the back end. But what summon does, then, which is very clever, is it will comb through the secrets.yaml, see that these are all the kind of identifiers, go off to the secret provider, grab the secret, essentially inject the secrets into the environment, fork a process, inject those environment variables in, and then let your process run with these environment variables in place. It also supports memory map temporary files. So that means the moment that you actually read from the file, that's it, right? So that's essentially what's happening here. Yeah, cool. So another part to focus on is I'm using summon, but summon has the problem where, well, it's not a problem as such. But let me take a step back, right? So we have an application running right now. Great. We have access to the variables, and these are exactly the same variables that we're able to see over here. But then let's suppose I decide to rotate them, because as I said earlier, the benefit of Conjur is that you get all the best practices for free. Like, it literally comes as part of your workflow. So you decide to modify the secrets, and well, it should be very straightforward to see that you don't actually need to change any application code in order for you to get the new value of the secrets. So as you can see, this value in particular has just changed. But then you might ask, well, why hasn't this value changed? Because if we go back, well, so I'm on this value. I will rotate the secrets just for illustration. So adds all the different values. And then I'm going to refresh over here. And you can see that the database password has changed. And there's a reason why it's the only one that's changed. So when someone actually kicks off a process, it injects environment variables, but that's it, right? It's not kind of hanging around and trying to update your environment. It's essentially saying, here's what you need in order to do your job. It's a different process in order to kill your application and restart it because the variables have changed. However, if you didn't want to do any of that, then Conjur, since it's API first, we have API wrappers for just about, well, whatever language you want. And it's very easy to kind of put together an API wrapper if you so decide. So if you ever look at the little bit of code that's happening here, all this is doing is actually, I'm using the Conjur Ruby API. I'm essentially authenticating using machine identity on that particular machine. And then I'm using the resource endpoint in order to grab my secret. And this secret identifier method is doing something cool, which is it goes into the secrets.yaml, and it allows us to essentially say, well, given this environment variable, what does it map to in terms of like a secrets.yaml Conjur identifier? So for example, with the database password, if we're in staging, it will go to staging my app database password. What's good about this is it means that every time that this route is actually hit by a client, we're actually dynamically retrieving that secret, right? So that means it's used as and when it's needed, and that's it. So there's two ways to do this. You can use summon, which allows you to inject things in. And this is very much for static secrets that you think are not going to be changing very much. But when it comes to something that's a bit more dynamic, you can have this means of essentially getting them when you need them. And what this means is, if we want to actually see the update for the other values, right, we actually need to redeploy. But instead of redeploying altogether, I've put together a really simple playbook, and what this does is it checks to see the process, if the process is running for the application. If it is, it kills it, and then we just restart. And you can see that I'm not actually modifying any application code. I'm literally killing a process and restarting it, and that's it. And that's essentially what I'm going to do now. So, sorry, that's restart staging. Great, so that's done. And if I go ahead and refresh here, you see that this has just changed. And everything is different now, right? Except the username, because that's just hard-coded. There was no intention of actually changing that. Cool, so that's one side of things. But then you might be like, well, hey, you haven't actually shown us the production side of things. Like, I thought you said, you know, we could have it all. And I'm going to go ahead and do that. So I can then just go ahead and do deploy production, and it is literally as simple as that. I didn't need to change any application code. I didn't need to go through some tedious process of like, hey, we're moving to production now. I needed to run deploy production, and that's it. So it goes through the same process. And in fact, there's something that I skimmed over. Before this is done, I'm just going to go ahead and come over here and list the hosts. So you can actually see that before this playbook is done, because it has an established identity for the 4 production containers that I have running, we only have 2 hosts. And early on, there were no hosts. There were just layers. And what actually happened is when I provisioned the staging environment using Ansible, the auto-enrollment essentially happened where you got this host set up, and then you got that other host set up. So it means the 2 containers that I have running have different identities, and if each one of them is compromised, then all of that is very easy to kind of track with the audit trail. So yeah, I've just run the very same thing for deploying to production. So let's have a look at the list of containers. Let me just jump to one of the production. And there you go. Oh. Well, that shouldn't say development. That's kind of weird. Maybe that's hard-coded. Yeah, I think that part is just hard-coded. Never mind about it. But you can see that the username, password, and Stripe API key are all production, right? So you have the different types. So this is great, right? You have your 2 different environments running in parallel. They can get changed, like the values can get changed independently. But then there's the piece that I mentioned, which is something along the lines of like you have role-based access control, and a huge part of that is being able to revoke. You want to be able to say that, okay, like this whole chunk of my infrastructure has been compromised. Let me immediately revoke access. And how do we do that? So the great thing about Conjur policy is declarative, right? So it means I shouldn't have to do anything imperative. It should be as simple as maybe commenting this out. So yeah, I comment this out, and I'm specifically going to update entitlements or update this policy only for the staging environment, right? So I have a script here, and that's all it does. It essentially replaces the policy. And I'm going to go ahead and run that. So that's 3, update entitlements, and that's for staging. And what that will do is essentially replace the policy that I had before with this one, where we haven't granted the layer this secret user's role. So now, if we run over to staging and we refresh, you can see that the two values that were provided by summon are still available because we can't really do anything with those because they're in the environment, they were passed in at the start of the process. But the database password is no longer available to us because now we're getting a 4.3. And in order to do that revocation, I didn't actually need to jump into application code whatsoever, right? And if we just take a moment to go back to production, you see that production is still perfectly fine. Like you've got two different branches of policy like operating independently, which is great. And when it comes to actually, I don't know, maybe bringing things back up, well, it's as simple as, uncommenting. I've fixed everything. Let me reinstate those permissions. This is very fast. Refresh, boom, I have the secret yet again. So these are some of the best practices that I mentioned earlier. You're able to get rotation, right? You're able to get easy revocation. Yeah, all that good stuff. And it comes right out of the box. And you don't actually have to invest anything in terms of actually getting this going because Conjur just kind of has it out of the box. And the great thing about the open source offering is you can kind of dive into the guts if you want. Great. So yeah, I've been yapping on the demo for a while. I think I'm going to give that a rest. Let's get back to that presentation. Great. So what are the trade-offs of using identity to retrieve secrets, especially within the context of Conjur? And I think the pros really mean that you get to eliminate overprivilege, right? You don't have a central attack target anymore. You have very fine-grained control of secret retrieval and updating and all that sort of stuff and kind of dictating your secret rules, or your security rules. Secrets are dynamically retrieved without writing a lot of code. If you actually go back and look at the foo.rb, the lines of code that were responsible for essentially abstracting the secret retriever was something like 10 lines. Like if you have 10 lines being introduced to your code base, I don't think that's very much. Yeah, so using identity enables teams to self-manage their application secrets because, as I showed, development, staging, whatever environment you can have different teams being responsible for different parts of your security infrastructure. And last but not least, and this is like probably the most, is that all access is authenticated, authorized, and audited. And this makes security very happy and the rest of the company because, well, you're making it, I guess, less likely that you get compromised. And when you do, it's very easy to kind of come back up from that. And in terms of cons, well, it's not very much, right? It requires a one-time playbook change. If you actually look at a playbook in the typical case and the playbook that I had, like it's a very simple change. It's the part where I added the Ansible role that we have for Conjur, which essentially establishes machine identity. So as I finish this off, I think that there's some truths that maybe we might say we hold to be self-evident, and I think it's possible to align velocity and security, and I think I showed that a little bit, and maybe that's something you can play around with as well. If security is a bad user experience, then I think everybody loses, and I think policy being declarative is an extremely empowering thing, right? It's you can scale much easier, you can reason about things much easier. It's great. And also, you can easily add secure dynamic secret retrieval to your playbooks and a host of other things, because this isn't something that just applies to something like Ansible. So let's suppose you're using Kubernetes, let's suppose you're using Docker, or, I don't know, Cloud Foundry. It's very much the same thing. As long as you can establish identity for, I guess, the atomic unit, which is your application, right? So in the case of Kubernetes, for example, it would be maybe a pod that's responsible for running your application. And this is where you want to isolate access. And it's very easy to do that if you've established identity, because if you have the identity of a particular pod responsible for the application, then it means you can have all the benefits of authenticate, authorize, all that sort of stuff. Yeah, so that's about it. And yeah, if you guys have questions, if y'all have questions, then I would be happy to answer those.
Yeah, one question. If I update a service with Ansible, with Playbook,
Yep.
would you then
Sorry, so you mean if you add the Ansible role to your playbook, sorry, what was the second part?
I've added all that stuff to secure my container.
Yep.
And so now I get the secrets by Conjur.
Yep.
And I'm updating my service. So my service is going from version 1 to version 2.
Yep.
So would we then recommend to also deploy new secrets to that container? Or would you take the old secrets and deploy them somehow? So how is this update process of my service with the secrets of Conjur merged?
Gotcha. Okay, that's interesting. So there's several ways that you could approach it. So if you're having V1 and V2 running concurrently, for example, then it's very easy for you to have a policy for V1 and V2. So it means you can have different secrets for your different versions of the application. But let's suppose that you're actually taking out V1 altogether. Then I think from a machine identity standpoint, if you're using the same machines, but you just have a new application, then you just need to update the secrets in Conjur. So it's very much happening out of band. In fact, you might not even need to modify anything in your playbook, because as long as the identifiers are the same within Conjur, your application will just get them anyway. Cool. I hope that answered it.
Where the secrets are actually stored, we have something similar to HashiCorp's old backends, where you can basically select where actually you want to physically store your secrets, or what's the approach you use here?
Okay, so in the open source version, and we can talk about other things later, but in the open source version, it's essentially we have a Postgres backend, and what we have is essentially the secrets are encrypted in the Postgres backend. So yeah, it's relatively simple there.
And clustering, is it part of enterprise offering?
Clustering. Yes, it is. So we have a high availability architecture that is quite robust. You have a master, a bunch of standbys, a bunch of followers, all that sort of stuff, yeah.
It's not part of open source?
No. Enterprise. Hey.
So what about a setup? Because you mentioned Cloud Foundry. So in Cloud Foundry, if I deploy a service,
Yep.
I can also specify the number of instances. So basically, my interaction with Conjur
Yep.
would be based on each separate instance. So how would that machine identity work? Would every instance have its own identity? Or would it be a single identity for all instances?
So I feel like for something like Cloud Foundry, you can pick and choose, but there is definitely an option for you to essentially have it so that if you have an application, then like Cloud Foundry has this idea of like service brokers, and using something like that, I think there's actually a limitation that you don't get any metadata per instance, and it makes sense anyway for kind of all of your different applications to kind of share the same host identity as a proxy to Conjur, because they essentially are the same like atomic unit, right? But if for some reason you decided to use the host factory way of doing things, then you could essentially have it so that every single application has its own host.
Each separate instance.
Yeah.
Yeah.
Okay. Yeah, like you have a choice, but I think what we're probably going to be pushing in terms of like Cloud Foundry is going to be something along the lines of like you have several instances of your application, especially in something like Cloud Foundry. There is practically no way for your different instances to be different, right?
I know.
Yeah.
That's one of the problems, because I've been looking into secrets management a lot.
Yeah.
And that's one of the issues with all these PaaS platforms.
Yeah.
If they don't actually have support for secrets management in them,
Yeah.
then it becomes problematic, because if you actually want to track each individual machine, you pretty much have to track the whole thing.
Right. But yeah, I think there's scope to be more granular, for sure. And the great thing about Conjur is, I think as you mentioned, like something like Cloud Foundry, yes, they offer a secret management solution, kind of. I don't know, like CredHub, but I think what companies generally want is something that's kind of like, you don't really get vendor lock-in. You want something that's like platform agnostic, and that's what Conjur is really. It's like, you should be able to come to us with any infrastructure you have, and essentially have Conjur be your secret management solution.
I do have one other question.
Sure.
Can you explain how the short-lived token works?
Yeah.
You mentioned Ansible gets a short-lived token.
Yep.
That one gets distributed for the deployment.
Yep.
Is it one token per machine? Or
No, so in the case of like, right now when I ran the deploy shell script, right, how that works is we generate right at that second a host factory token, and that host factory token, you can specify how long it should live for. And what we did there is we said that it's going to live for 5 minutes. And as we run the playbook, we make it available within the environment variables for the playbook, for example. So then what actually happens is the role for Conjur then essentially establishes machine identity for every single one of them using the same token. Because if you present a token that is valid to Conjur, then especially if that particular token is kind of linked to a particular layer, then we create a host for you, add you to that layer, and that's it. And when it expires, done. Cool. Thanks. All right. I think that's it. Thank you so much for coming. If you want to check out Conjur, I would say head over to conjur.org. We have some really good tutorials. The intention really is for it to be very easy to get up and running with Conjur, and I think we've done a good job of that. So if you want to play around with Conjur, by all means. If you want to check out the demo that I just gave, you can perfectly do that. There's the URL right there. We have a Slack channel. I'll be around if anybody has questions on the Slack channel and outside as well. And yeah, thank you.